raindrops. Each one is just a few millimeters in size. But they can release an enormous force during storms on the North Sea. The rotor blades of offshore turbines cut through the damp air. The blade tips reach speeds of more than 300 kilometers an hour. And the raindrops hit them like bullets. It's not just a problem for wind power generators out at sea. Even on land, rain hits the blade tips of wind turbines with a force 100 times stronger than normal. But the blade surface has to withstand such forces for more than 20 years, a problem that BASF developers are working to solve.
The use of wind power to produce energy has increased massively in recent years, and it will continue to grow in the future, not only here in Germany, but all over the world. It's extremely important for the wind farm operators that the generators function without interference, so the operation remains economical.
To make sure the blades can withstand the impact for long periods of time and keep producing green energy at a low cost, developers test the blade coating in their own laboratory. They mount test pieces on the rotor. The pieces are designed to fit into the blade's cross-section, and they're covered with a green protective coating.
So the last piece is in place. Great.
A special camera observes the procedure. For safety reasons, people must leave the room during the trial. From outside, they accelerate the rotor to 500 kilometers an hour. That way, they can simulate the long-term effects of rain.
It's a good test because it creates a rotation that's just like the real thing. But at 500 kilometers an hour, it's a lot faster than normal. So if the test pieces endure it in here, they can take it out there as well.
And here it goes. The rotor is slowly accelerating to its maximum speed. Small nozzles spray water drops onto the test pieces. The extreme slow-motion camera allows BASF developers to observe a process that normally lasts only a few 10,000ths of a second. The protective coating withstands the impact during the initial rotations. But it doesn't take long for the first damage to appear on the protective coating, and the damage gets worse and worse. After just a few minutes, the developers stop the trial. The water drops have badly damaged not only the protective coating, but the synthetic material underneath as well.
If wind power generators display this kind of damage, they usually have to be taken offline, and that results in substantial economic losses.
To extend the operating life of rotor blades, technicians further develop the protective coating. Their goal is to protect the surface of the blades from raindrop erosion for 2 decades if possible. One important component of the protective coating is polyurethane. The synthetic material is made of 2 different molecules with different ends. The ends are where the molecules connect, releasing a certain amount of energy. Long, stable chains form. Other forces are also at work between these chemical connections. The individual chains attract each other, creating a complex, flexible, and three-dimensional polyurethane structure. The developers subject the new coating to numerous tests, like spreading it on a sheet metal panel. After the coating has dried, the panel is bent. And thanks to the flexible qualities of the coating, no cracks appear on the surface.
People usually think the harder the better, but oftentimes a flexible material is a better protection against high-impact flexible material like raindrops.
The technicians try out the new flexible coating in a rotary test. Again at 500 kilometers an hour. The water drops are hitting the test piece with 3 times the force that wind-driven rain hits the rotor blades out at sea. The results are clear. No damage is visible. Achim Gast is in charge of wind energy at BASF subsidiary Relius.
The coating materials not only protect the wind turbine from rain erosion, but also from UV rays and sand erosion. For turbine operators, it's extremely important to keep the generators running at all times, increasing the overall economic viability.
Rotor blade assembly at Bard in Emden. Blades measuring nearly 60 meters and weighing almost 30 tons are produced here. In the last production stage, they're covered with the BASF protective coating, which also comes in different colors. Some of the paint is brushed directly into the mold. Technicians apply a layer just a few tenths of a millimeter thick. Afterwards, the rotor blade is assembled layer by layer in the coated mold.
The coating is very important. Without it, rain would immediately attack the blade's materials, and the coating prevents that. In recent years, we've done some very good and innovative work with BASF, and development is very important for the future. That way, we won't have to change the blades for at least 20 years.
And that is a must. The rotor blades are installed at the Bard Offshore 1, located 90 kilometers off the German coast. Never before have wind turbines been built this far out to sea, where damage to the rotor blades would have fatal consequences for the economic viability of the entire project. Together with additional farms, wind energy is expected to become an important pillar of our energy supply. With its new highly resistant coatings, BASF is making a major contribution to the ability of wind farms to run smoothly around the world. Wind power can compete in our future energy mix, even under high winds and extreme weather conditions.
BASF, the chemical company.